welcome to you. Really nice to have you here with us. We are in the middle of our winter school. So far, we have done 2 lessons in this particular course. We have done multiplying fractions and we have done dividing fractions, which were 2 lessons that you guys seem to really enjoy and make a lot of progress with. So I'm hoping that today's lesson will be as exciting and as interesting for you as well. I really do want you to be able to understand how to do all 4 operations with fractions really well, because it's going to make a big difference for you, not only this year in grade 7, but for you going forward into grade 8 all the way through to matric. Okay, so we're going to get started now with adding and subtracting fractions, which is not something that we have spoken about before. And before we jump in and we start talking about how we actually do it, I just want to spend a little bit of time talking about why do we have to do it, right? So now, can anybody tell me, what do we need when we want to add and subtract fractions? We need something that we didn't need previously. So we didn't need it when we did multiplying, and we didn't need it when we divided. So what do we need when we add and subtract fractions? Tatelo, go for it.
Ma'am, is it the lowest common multiple or denominator?
Absolutely. So you need a lowest common denominator, known as the LCD, or as you had called it, the lowest common multiple. Now, Tatelo, you're quite right. We do need an LCD or an LCM, but why? Why do we have to have one? Can you explain that to me?
Ma'am, because the denominators have to be the same before you add them. Otherwise, it wouldn't be possible to add or subtract them.
Absolutely, Tatelo, that's a really lovely explanation. Absolutely. So I went in and I did a little bit of digging today. And I don't know if I can improve upon what you're saying, but let's use this example. All right. So if you have a look at the screen at the moment, let's say you wanted to add a half and a third together. All right. So the half is represented in the green and the third is represented in the purple. So as far as the half is concerned, we've taken a rectangular block and we've cut it in half, right? And we've shaded in green the half that we want to add. The same size block has been divided into 3 equal pieces and we've shaded a third. And then what I've done is I've cut them out and I've stuck them over here. All right, so you can see me moving these blocks around. So now, how am I going to add these 2 together in a meaningful way? Well, as long as their denominators are different, they're never going to change from being what they are. Okay, so in other words, I can put them together any way I like, but I don't really have an understanding of how much a half and a third is when I leave them in this form. Okay, so you can see me moving them all over the screen and putting them next to one another and on top of one another, and it still doesn't give me an idea of how big this fraction is. How many parts out of a whole have I actually got? Right? That's why we need a lowest common denominator or lowest common multiple. So in the case of a half plus a third, what we are doing here is we are choosing a number that is both a multiple of 2 and a multiple of 3. That's why we call it a lowest common denominator or lowest common multiple. So we look at our 2 times table and we look at our 3 times table. Our 2 times table, well, 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. Now, if we look at our 3 times table, 3 times 1 is 3. 3 times 2 is 6. There we go. Okay, so looking at our times tables, we can now see that we have got 6 in common in both. That's why we call it a lowest common denominator or lowest common multiple. And what that means is that we now need to make the half into 6 and the third into 6. Okay, so that the block has been cut into pieces that are the same size, so we can add them together to see how many parts of the whole we've got. All right, so what we're going to do is we're going to change our denominator. So we're going to change this 2 into a 6, quite right. So what do I need to multiply 2 by to get it to 6? I've got to multiply it by 3. All right, so the factor by which I have changed the denominator is the same factor by which I have to change the numerator. All right, so this is going to give me 3 out of 6, which we know is the same as 1 out of 2. Right, and then I'm going to do exactly the same on this side. I'm going to make the 3 into the 6 by timesing it by 2. And what I do to my denominator, I've got to do to my numerator as well. And that's going to give me 2 out of 6. And now that my denominators are the same, I'm going to keep my denominator and I'm going to add my numerators together. So 3 plus 2 gives me 5 out of 6. And now I can understand that when I add a third and a half together, how many parts of a whole I've got. So essentially what I've done is I've taken that block and I've gone and put it over here. And I've taken another block from there and I've put it over here. And I've taken the last block and I've gone and put it over there. And now you can see I've got 1, 2, 3. Let me put numbers on them instead of just talking about it. I've got 1, 2, 3, 4, 5 out of a possible 6 blocks. Okay, so that's why we have to use a lowest common denominator when we are adding or subtracting. That's where it comes from. How does everybody feel now? Do we feel good? You can give me a thumbs up or a thumbs down or a smiley face in the chat. Are we feeling good about this? Okay, I think it's important that we understand why we have to do something instead of someone just telling us that we must. Good stuff, lovely. All right, now we can go and have a look at some examples. Before I do that, lovely, thanks for all your smiley faces. Those are awesome. Thank you, thank you, thank you. Okay, Olwa, you had a question. Do you want to ask me something, Olwa? No? Okay. All right. So let's go and get started. Now we know why we have to do this. Let's go and put it into practice. Okay. So, yes. Who's that?
That was Olwa.
Oh, was it Olwa? Olwa, do you want to ask something?
I wanted to ask if we're doing lowest common multiples, because I wasn't sure. I was 9 minutes late.
No, that's fine. We're not doing lowest common multiples. We're talking about how we use the lowest common multiple in order to find a denominator when we add and subtract fractions when our denominators are different. That's what we're talking about. So today's lesson is about adding and subtracting fractions.
Okay.
Okay, all right, no problem. Tatelo, I see you've got a question.
Ma'am, it's not a question.
Did you want to answer? Did you want to try one of the questions?
Yes, ma'am.
All right, lovely. Okay, well then I'll tell you what I'm going to do. I'm just going to make this just a little bit bigger so that everyone can see. Okay, Tatelo, you do number 1. You tell us what we're supposed to do with this question.
Yes, ma'am. First of all, you say how many times does, okay, ma'am, so what I did was 4 times 5. So what you do at the bottom, you do at the top. So 3 times 5, 4 times 5, which equals to 15 over 20, plus 2 times 4 and 5 times 4, which equals to 8 over 20. And then 15 plus 8 is 30. 23 over 20. If
Absolutely.
I'm wrong.
You didn't go wrong anywhere. That was wonderful. Well done. Okay, that's exactly the right thing that you need to do. Okay, now maybe what they expect you to do at school is to write it as a mixed number. When you get to high school, they don't. So at high school, you can leave it as an improper fraction just like that. But if they did expect you to write it as a mixed number, what would you do now, Tatelo?
Ma'am, I'm not sure, but I think I'll simplify.
Okay, so what you got to do now, Tatelo, is you've got to say to yourselves, how many times does 20 go into 23? It goes in one whole time. Okay, what's your remainder? Your remainder is 3
3
out of
over
20.
20.
Okay, all right, but that's not that important to be able to do that in high school anyway. I don't know, maybe in primary school it's different, but at high school we don't expect you to write a number as a mixed number. If there are no more common factors, you can leave it as an improper fraction. Okay, Tatelo, you did that really, really, really well. Okay, Asher, you've got a question. What's your question, Asher?
My question was, before she did it, the fraction, I wanted to ask if like we're supposed to like write it down on a book or we can just see on the phone.
Yes. So the idea is that you should try and write as many of these down and try and do them as well by yourself and then with me together. Absolutely. Okay. So we can't get better at maths by watching somebody else. All right. We've got to get better at maths by doing it ourselves. Okay. So yes, absolutely. All right. So now, Asha, since I've got you, how would you do number 2?
Number 2, I'm not really quite sure on how to add a whole number and a
fraction together. Okay, all right. Well, let's see if there's somebody out there that can help you. Anybody able to help? Oh, Rolivua got her hand up. Rolivua, can you help Asha answer question number 2, please?
Yes.
Go for it. What would you do, Rolivua?
1 plus 9/5 is 1 and 9/5 if you put it in a mixed fraction.
Mm-hmm.
And
Or
if you put it in improper, you can say 5 over 5 plus 9 over 5.
Correct. All right. So what have you done with the 1? Essentially, you've taken 1 and you've written it as
a fraction.
As a fraction. Okay, so you said 1 is 1 over 1, and if my lowest common denominator is 5, I've got to times there by 5, and I've got to times here by 5. Absolutely.
Yes.
All right, keep going. You can finish it off. You would keep the
5, and then you would say 5 plus 9, which equals 14.
Absolutely.
So it's 14 over 5.
It certainly is. Well done. That's very good. Nice, Rolivua. Okay, Asha, hopefully that's making a little bit more sense. Okay, Ayanda, go for it. Do the next one.
Ma'am, you're going to say 7 times 2, ma'am.
Uh-huh. And what's that going to give you?
Ma'am, 7 times 2 is going to give you 14, ma'am.
Lovely.
Ma'am, and then you're going to say 2 times 7, ma'am.
Okay.
We're going to give you 14, ma'am. And then what you do to the bottom, you do that to the top, ma'am.
Absolutely. So what am I going to do to the 13?
Ma'am, I'm going to say 13 times 2, ma'am.
Lovely. And that's going to give me?
26.
Good.
And then, ma'am, I'm going to say 3 times 7, ma'am.
Lovely. And that's going to leave us with?
21.
Good job. And that's going to give us what?
47 over 14, ma'am.
47 over 14. All right, that's really, really good. Well done. Okay, you guys are actually very, very good at this. All right, that's really nice work. Well done. Okay, let's try a minus and 1 now. Okay, let's have a look at number 4. I'm super, super impressed. Motibang, do you want to do number 4 for us?
No, ma'am, I just want to tell you something. It's just that
Okay.
I don't understand because it's load shedding and that's why I logged off. My Wi-Fi is old and wonky.
Oh, I'm
It's
sorry.
unstable.
Okay, all right. So you're just struggling a little bit, are you?
Ma'am?
You're struggling a little bit with your Wi-Fi.
Ma'am?
Okay, Snokuhle, do you want to do
Teacher
number 4?
Yeah.
Okay, Snokuhle, you can do number 4 for us?
Yes.
Number 4 is
Yeah, it's just that I have like 2 Wi-Fi's. There's one that is a modem and there's one is a router.
Okay, Motibang, thank you so much. Okay, I'm going to call on you just now for an answer, all right? Okay, so Nokuhle, go for it. How would we do number 4?
Hi, Miss. So for number 4, we're gonna take, I think, 7 times 8. 7 times 8. And again, there's 7 times 8. I mean, 7 times 8. And on top 2 by 5, we're gonna say 7 times 8.
So what must I multiply? What must I times the 5 by?
7.
Good. And what must I times the 1 by?
8.
Lovely. Good job. Okay. So now what am I going to end up with?
7 times. It's 50. 7 times 8 is 56.
Yes. And then in the numerator, I've got?
7 times 5 is 35.
Good. Well done. All right. And then on this side, I've got the same denominator. 1 times 8 is?
56. And the numerator is 8.
Lovely, Snokukle. Okay, now what are you going to do?
I'm going to say 35 minus 8 gives you 27.
Lovely. So I've got 27 out of?
56.
Good. Well done, Snokukle. That's really good. Lovely, lovely, lovely. Okay, nice job. All right. Let's go on to another one. Let's go and see if we can maybe find something that is a little bit more challenging. Okay, why don't we have a look at number 10? Okay, let's see who's going to do number 10 first. All right. So, Bonolo. Hello, Bonolo. Do you want to do number 10?
Oh, ma'am, I was raising my hand to answer number 6.
Okay, you want to do number 6? That's
Yes,
fine.
ma'am.
Go for it. You're welcome to. Okay, let's do number 6. Go for it.
Okay, ma'am. So I multiplied 7 by 2
Okay,
and it gave me 14.
good.
And I multiplied 1 by 2 and it also gave me 1 multiplied by 2, it gave me 1.
No, 1 multiplied by 2 can't give you 1. 1 multiplied by 2 has to give you 2.
Oh, ma'am.
That's it. Don't worry. Don't worry. Good. All right. You're on the right track.
And then, ma'am, I said 3 multiplied by 7.
Okay. And what did that give you?
3 multiplied by 7, it gave me 21.
Lovely. Okay. And then at the bottom, you also had?
I also had 14.
Good. That's great. So now what are you going to do, Bonolo?
We're gonna add them.
We are indeed. Okay. So we're going to add the numerators and we're going to keep the denominator. Okay. So how much does that give us in the numerator, Bonolo?
It gives us 22.
23.
3. Oh,
23. No, it's okay. Don't worry. It doesn't matter if you make mistakes. I make mistakes all the
Oh,
time.
ma'am, I can't see my handwriting properly because I wrote it in a rush.
That's okay, Manolo, don't stress. Okay, so that would give us 23 out of 14. All
14.
right, good. Yes, that's excellent. Well done. You did that beautifully. I'm so impressed. You guys are so clever. I think these questions are far too easy for you. We need to do more difficult work. Patson, which one did you want to do, Patson?
Ma'am, you said that we must do 10, ma'am. Can I try do 10?
Yes, absolutely. Do number 10, Patson.
So, ma'am, since 7 was a whole number, ma'am, I put 1 under it.
Okay,
And
I
then
agree.
I said, and then I looked at the quarter and like 7 and 4, they don't exactly have the same factors. But what I decided to do was I decided to take the 4 and I decided to times it with 1 and 7.
Okay, so what was your lowest common denominator with the 7 and the 1? What did you change the 1 into?
Ma'am, I changed it into 4.
You changed it into 4, absolutely. Okay, so you said this. So you said 1 times 4 is 4.
Yes, ma'am.
Okay, and then what did you do to the top?
I said 4 times 7.
Lovely. Okay, and what did that give you?
It gave me 28 over 4.
Lovely, that's very good. Okay, and then what did you do with the 1 over 4?
Ma'am, I left it.
You left it as it is. Okie doke. So you got it, you ended up with that.
Yes,
and your
ma'am.
final answer was?
27 over 4.
Indeed. Okay, very good. Well done. That's excellent. Beautifully, beautifully, beautifully done. I'm really, really impressed. Okay, Chinolo. Chinolo? Which one were you wanting to do?
Ma'am, number 8.
Number 8. Okay, let's go and have a look at number 8. Okay, there we go. All right, so Chinolo, you do number 8. What would we do here?
Ma'am, I said 5 times 2.
5 times 2. Why are you timesing by 2?
Ma'am?
Why are you timesing 5 by 2? Can you explain to me? It's not wrong. I just want you to tell me why you're doing it.
Because I have to.
What do you have to do in this question? What's the first thing that you're trying to do here? You're trying to make the?
I'm trying to make the
Denominators
look the same.
Oh, lovely. I love it. Okay, so what have you decided you're going to use as your denominator here? What number are you using?
2.
2. Okay, but is 4 in the 2 times table?
Yes, ma'am.
No, it's not. No, it's not. Okay, so 4 is in the 2 times table, but 2 is not in the 4 times table. All right, so in other words, if we use a lowest common denominator of 2, what are you going to multiply 4 by in order to get 2?
4 times 1.
But 4 times 1 is not 2. 4 times 1 is?
4.
Is 4, absolutely. So what you need to do here, Chinolo, is you need to look at your denominators. Those have got to be the first things that you look at. You look at 4 and you look at 2, okay? So it's always got to be either the biggest number or a number bigger than that, okay? It can never be the smallest number because then it's not a multiple. All right, so now you've got to say it to yourself, all right, now I'm talking about the multiples of 2 and 4. So 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. Okay, 4 times 1 is?
4.
4, good. 4 times 2 is?
8.
Absolutely. Now, can you see you've got 4 here and you've got 4 there? If you went back here again, though, and you said, so 2 times 1, 2 times 2, 2 times 3, 2 times 4, you would get 8 up here as well. So if you wanted to, you could use 8 as a lowest common denominator. All right, so it's your choice. Either you can use 4, that's the lowest common denominator, or you could use 8. Which one do you want to use?
4.
4, all right, lovely. So if you're going to use 4 as a lowest common denominator, do you need to change the first fraction? Does this have to be changed in any way?
Yes.
Okay, it doesn't have to be changed, Chinolo, because we've already got a denominator of 4, which is awesome. So the only denominator, the only fraction that we need to change and give it a denominator of 4 is this one over here. Okay, so what we're going to do is this. We've decided that we're going to use 4 as our lowest common denominator. So 5 over 4 will stay as 5 over 4. Now I need to make that 2 into a 4 using multiplication. So I'm going to say 2 times what to give me 4?
2 times 1.
2 times 2 is going to give me 4. Okay, and when I multiply the bottom by 2, I've got to multiply the top by 2 as well. So 1 times 2 gives me
2.
Lovely, well done. That's great. Now what am I going to do? I'm going to keep the denominator. And what am I going to do with the numerators?
You're gonna add them.
Lovely, Chinolo. And what are we going to get in the numerator?
7.
Lovely. Yay. Well done. That was great. Good job, Chinolo. Okay, you did that beautifully. Very, very impressed. Okay, Ramkhuato, you're up next. Which one do you want to do, Ramkhuato?
Number 5.
Number 5. Okay, let's go. Okay, go for it. Do number 5 for us, Ramkhuato.
With the one I said 5 over 5 plus 3 over 7.
Oh, there we go. Sorry, I'm looking at the wrong one. Okay, so in number 5, you said what over what?
For 1, I made
Yes.
it a fraction as 5 over 5.
Okay, so you made it 5 over 5. Why did you choose 5 as the denominator?
Ma'am, I wanted to make it more simple so that I can get the 7 as like, it's just that it's complicated for me to explain it. I was gonna explain it with my own language, but
okay, all right, well, leave it as 5 over 5 for now, and then you're going to write the next fraction, right, which is plus 3 over 7.
yes.
And then what were you going to do?
With the 5 over 5, I was gonna multiply both of them with 7.
Oh, okay, all right. So in other words, you're going to times that by 7, and you're going to times that by 7. Okay.
Yes.
All right, that's fine.
Then
and what would that
3
have given
over
you?
3 over 7, I'm gonna multiply 3 by 5 and 7 by 5.
Oh, okay. All right, lovely. So in your second line, what are you going to have then?
For the 5 multiplied by 7, it gave me 35 over 35.
Okay. Lovely. Keep going.
Plus 15 over 35.
All right. That's not wrong at all. Keep going. Yes.
For my answer, I got 50 over 35.
Okay. For your answer, you got 50 over 35. Now, what would happen if you left your answer as 50 over 35, do you think?
I was supposed
think
to
you might
make it
lose? Would you lose a mark maybe?
No.
Okay, well, unfortunately, you would if you were in grade 7 or grade 8 or grade 9, because they always want you to simplify your fractions. So that means that there's something at the top, a number that you can divide into 50, that you could also divide into 35 in order to simplify those numbers. Do you know what number it is?
No.
That's okay. That's all right. So if a number ends in 5, right, it means that 5 has to be a multiple of that number. Okay. If a number ends in 0, either a number ending in a 5 or another number ending in a 0 is going to be a multiple of that number. So what I'm trying to say is both 50 and 35 are in the 5 times table. Okay, so what you can do here, Rankuato, is you can divide the top by 5. And what you do to the top, you must also do to the bottom. Okay, so what's 50 divided by 5?
10.
Good job. And 35 divided by 5?
7.
Good job. Okay, now your fraction is completely simplified. Okay. All right, now I just want, well done, Rankuata. I agree with you. All right, now, Olwa, you've asked a question. Why did we change it to 5 over 5? I agree. I just want you to see where Rankuata was going to go with this particular question. All right. If you had done this question, what would you have made? Instead of writing 5 over 5, Olwa, what would you have written?
I would have written 1 over 1.
Okay, and then what would you have done with your 1 over 1?
I would have said 1 over 1 plus 3 over 7.
Okay, how would you have done that? Explain to me what to write.
You would like say 1 times 7.
Okay.
And then what you do to the bottom, you do to the top.
Okay.
And then you would say 7 times 1 and 3 times 1.
Okay, so then here you timesing by 1 and there you timesing by 1. Okay, so in other words, what you're saying is you would have rather written 1 over 1 as 7 over 7 instead of 5 over 5.
Yes.
I agree with you, Olwa. That's what I would have done there too. All right. What Rankuato did wasn't wrong. It was just a little bit longer. Okay. But what you're doing here means that you're not going to have this additional step at the end of having to simplify, because you've got 7 over 7 plus 3 over 7. And then you would have kept the 7 at the bottom and you would have gone 7 plus 3 is 10. Exactly. And can you see you both ended up with the same answer? Okay, yes. Yours was just a much quicker way. All right, but that's why I wanted to talk about it. So thank you for asking that question, Olwa. It means you're really thinking things through, and I'm really proud of you for that. Well done.
Could I please do number 9?
Okay, go for it. Do number 9. What would you do here?
So you would say 2 times 7.
Okay.
And then what you do to the top, you do to the bottom.
Okay.
And then you just leave it like that because 8 can go into 4. So you just change that bit.
Okay. All right. So 4 can go into 8. So your first fraction is going to be what out of 8?
14.
Beautiful. And your second fraction is going to stay as?
The same. 5 over 8.
Lovely. Good job. And now what are you going to do?
You're going to add them and leave the denominator the same.
Exactly. So you're going to leave the denominator as 8, and then you're going to add 14 and 5 together, and that's going to give you
19.
Lovely. Good job, Olwa. Well done. That's great. Excellent. Well done. No, thank you. Well done. Ayanda, I see your hands up next. Ayanda, do you want to do one?
Yes, ma'am.
Okay. Ayanda, can we do a difficult one?
Okay, ma'am.
Okay, so if I take you all the way down here and I said to you, Ayanda, you have to do number 1. What
ma'am.
would you do here? Would you be able to tell me what to write?
Yes, ma'am.
Okay, all right, go for it, Ayanda. What should we do with this question?
Ma'am, you're gonna say 5 times 2 plus 1.
Lovely, and that's going to give you?
11, ma'am.
Lovely, so that's going to give you 11 over?
11 over 5.
Exactly. So what are you doing when you take the 2 and 1 over 5 and you make it into 11 over 5? What is that called with what you've done?
Beg your pardon, ma'am.
What's it called? What have you done to 2 and 1 over 5 when you made it into 11 over 5? It has a name. What have you called it? What have you done to it?
Ma'am, I'm not sure, ma'am.
Oh, okay. All right. Anyway, it doesn't matter. What you're doing is correct. So when you've got 2 and 1 over 5, that is a mixed fraction.
Oh,
Okay. And then when you changed it and you made it into 11 over 5, we call that an
improper fraction.
improper fraction. Very, very good. Okay, so Ayanda, I love what you're doing here. Okay, we're going to take mixed fractions and we're going to make them into improper fractions. How did we do that again? Tell me what you said. You said?
Ma'am, you for the second one, ma'am.
You could, oh, absolutely. For the second one, tell me what you're going to do.
You're gonna say 4 times 1 plus 3, ma'am.
Lovely. 4 times 1 plus 3 gives you?
7 over 4.
Excellent. All right, and now what are you going to do, Ayanda?
Ma'am, you're gonna add 11 with 7, ma'am.
Can you do that? Look at your denominators. Are you allowed to do that?
No, ma'am.
No. Okay, so remember, if we add and subtract fractions, our denominators have got to be the same. Absolutely. So now we've got to ask ourselves, what number do both 5 and 4 go into?
20.
Lovely. So what are you going to multiply the 5 by?
4, ma'am.
Good job. And you're going to multiply the 11 by?
4.
Good. And on this side over here, you're going to multiply the 4 by?
5, ma'am.
Good job. And you're going to multiply the 7 by?
5.
Excellent. Okay, so now you've got what over what?
Ma'am, you've got 11 over 20 and 7 over 20, ma'am.
Okay, but now you've got 20 at the bottom, but is 11 times 4 11?
11 times 4. Oh, ma'am, I forgot to times it, ma'am.
That's okay. So when you times 11 by 4, what do you get, Ayanda?
Ma'am, I'm still counting, ma'am.
Oh, okay.
$44, ma'am.
44 is correct, absolutely. Sorry, I'm just replying to someone. That's it, Panola. You put the right answer there as well. Okay, so you've got 44 over
20.
20. Good job. Okay, and then on this side over here, we've got what over 20?
35 over 20, ma'am.
35 over 20. Excellent. Okay, and now we're going to keep the denominator of 20, and we're going to add
44 plus 35.
Beautiful, Ayanda. And what would you get there?
79, ma'am.
79. Lovely. Well done, Ayanda. That's really, really good. Okay, I am super, super impressed. That's great work. Okay, let's see who's up next. Hang on one second. Lesejo, do you feel brave enough to try one of these questions? Do you want to try number 2? Lesejo?
Ma'am, it looks hard.
It is, but you know what? I'll help you through it. Okay, I'll help you through it. Right, we'll do it together, okay?
Yes, ma'am.
All right, that's it. All right, now the first thing that we want to do is take 3 and 1 over 2, which is a mixed fraction, and we want to make it into an?
Proper fraction.
Exactly, an improper fraction. And how do we do that? How do we make mixed numbers into improper fractions?
Ma'am, I'm not really sure.
Okay, so what we do is this. If you heard what Ayanda was doing in this question, okay, he took the denominator and he times it by the number in the front. So he said 5 times 2 plus 1. Okay, and he added the number at the top. So 5 times 2 is 10, plus 1 is where he got the 11 from. Okay, and then we keep the same denominator. We keep the 5 at the bottom. Okay, so now if we look at this one over here, you have to say 2 times 3 plus 1. What is 2 times 3 plus 1, Lesejo?
2 times 3 is 6 plus 1 is 7.
There we go. So your first fraction as an improper fraction is 7 over 2. Excellent. Okay, you do 2 2/3 by yourself. Tell me what you should get as an improper fraction.
2 times 3 is 6 plus 2 is 8.
Marvelous. And what are we going to put the 8 over?
We're going to say 8 over 3.
There we go. You see, you can do it. You can do it. That's wonderful. Now, we're subtracting fractions. Can the denominators be different?
No.
No, absolutely. So now we look at the 2 and we look at the 3 and we say to ourselves, what's going to be our lowest common multiple of 2 and 3? What number do both 2 and 3 go into?
1.
1.
No, so 2 and 3, 1 goes into 2 and 1 goes into 3, but it's got to be a number that's bigger than 2 and bigger than 3. So think about your times tables. So 2 times 1 is?
2.
2. 2 times 2 is?
4.
4. 2 times 3 is?
6.
6. Okay, now let's go and do our 3 times table. 3 times 1 is?
3.
3. 3 times 2 is?
6.
Lovely. Okay, now what do you notice?
They both go in 6.
Okay, so both 2 and 3 go into 6. So that means that we can use 6 as our lowest common multiple. All right, so what am I going to multiply 2 by to get 6? I'm going to multiply it by?
3.
Excellent. What do you need to multiply the 7 by, Lesejo?
3. What you do at the
Excellent. Exactly what you do at the bottom, you do to the top. Quite right. And on the other side over here, what am I going to times this 3 by?
3.
3 times 3 is 9. 3 times what is 6? Remember, 6 is our lowest common multiple?
2.
Good. And what am I going to multiply the 8 by?
2.
There we go. Good job. Okay, we're nearly there. Now you have to tell me, what is 3 times 7?
3 times 7 is 21.
Excellent. And 3 times 2 is?
3 times 2 is 6.
That's it. That's our lowest common denominator. And now 8 times 2 is?
16.
Excellent. Over 3 times 2 is?
6.
Excellent. Okay, now what are we going to do, Lesejo?
We're gonna subtract the numerators.
Okay, we're going to keep the denominator and we're going to subtract the numerators. Beautiful. So 21 minus 16 leaves us with how much?
Five.
21 minus 16 is?
5.
Beautiful. There you go. You see, we must never, ever, ever tell ourselves that we can't do maths. Okay, we can all do maths. All right, that's wonderful. Well done. I am super, super, super impressed. Okay, let's see who's got Inas. Oh, it's so nice to hear from you, Inas. Would you like to do one of these questions? Which one would you like to do?
Number 3.
Number?
Number 6.
Number 6. All right, go for it, Inas. What should we do here in number 6?
2 times 3 is 6 plus 1, 7 over 2.
Lovely, good job. Keep going. That's nice.
9 times 2 is 18 plus 5 is 23.
Well done, Inas. That's very good. And what's your denominator going to be?
9.
Excellent. And now what are you going to do, Inas?
Then I multiply 7 and 2 plus 9.
Okay, so what am I going to multiply the 2 by?
9.
9. Okay, and what am I going to multiply the 7 by?
9.
9. Lovely. Okay, and then am I going to multiply the 9 by anything?
2.
By 2. Okay, and what am I going to multiply the top by?
2.
Lovely. All right, so now my first fraction is going to be what?
63 over 18.
Lovely, 63 over 18. So 9 times 7 is 63, and 9 times 2 is 18. Lovely, and now do the next one for us. 23 times 2 is?
46.
Good, Inas. Over?
18.
Lovely, well done. Okay, and what are we going to do with the 18? We're going to keep the 18 as the denominator. And now at the top, we have to say 63 minus 46. What's that going to give us? You get 17? 16.
15.
Oh, goodness me. I'm struggling to hear you a little bit.
I think he's in the car.
Oh, okay. All right. But 17 is correct, isn't it? Oh, Inas, you did that really well. Good job. Well done. I'm super, super, super impressed. Okay, let's see who else would like to have a go. Tato. So nice to hear from you, Tato. Which one would you like to do, Tato?
Let's do number 9.
Number 9. All right, let me go and find number 9. Where is it?
Up there.
Oh, there we go. There's number 9. Okay, go for it. Go for it, Tato. Do number 9 first, please.
Yes, I multiplied 3 times 2 is 6. Then I added with the 1. It's 7.
Good.
Then I wrote 7 over 2.
Lovely.
Then I said 1 times 2 plus 1 is 3. I wrote 3 over 2.
Excellent. Well done.
Then I subtracted 7 minus 3.
And what did that give you?
4.
Lovely. Over?
2.
Okay. And then what did you do?
Is it an improper fraction?
It is an improper fraction title, but just like I was saying to, was it Lesejo earlier, or was it Bernard? I can't remember who did this first. Was it Ayanda? No, it wasn't. Ayanda did do that one, but it wasn't that one that we were talking. It was this question over here. Do you remember at the end here? I can't remember who I did this with. But remember, we ended up with the 50 over the 35. We were not allowed to leave that because both the top and the bottom can be divided by the same thing. So we can only leave things as improper if there are no common factors left. All right, what can we do with 4 over 2 though?
I'm not sure.
Okay, what does 4 over 2 mean, Tato?
It means
4 over 2 means 4 divided by 2. Okay, so this line over here means divide. Okay, now it becomes quite easy. 4 over 2 means 4 divided by 2. So 4 divided by 2 is?
Let me check. 2.
There we go. Beautiful. All right, you've done it. Well done, Tato. That's lovely. Excellent, excellent, excellent. Okay, let's see who else has got a hand up that we haven't heard from in a while. Oh, Ray2. Ray2, which one do you want to do, Ray2?
No, que você diz. Mas I know what you.
Rachel,
Number
there
3.
we go. Oh, there you are. Okay, Rachel, which question are you going to do?
Number 3.
Number 3. There we go. All right, go for it, Rachel. Tell me what to write.
You write the same thing as here. 3. It's number 3.
Okay, so what should I write here?
The same.
Oh, so must I still write 3 and 1 over 2?
Yes.
Okay, minus 3 and 1 over 2, and then what should I do now?
No, down. Write 1 over 2 again, down.
Write 1 over 2.
Down.
What do you mean down?
Not like that. 3, 1 and 2 down.
I don't understand what you mean. So I've written 3 and 1 over 2. Okay.
Yes.
But Rachel, before you get started on this question, what do you notice about both the fractions? What do you notice about this and this one?
They are the same.
They are the same, absolutely. So in maths, when we subtract something and we subtract something from itself, what do we always end up with as an answer? So if I have, so if I say 5 minus 5, what am I going to get?
0.
Okay, and if I say a quarter minus a quarter, what am I going to get?
8 minus 1. 1 to 8.
Okay, but if I'm subtracting the quarter from itself, then surely I'm going to end up with 0 as well. Does that make sense? So anything minus itself is 0 in maths, okay? Whether it's a whole number, whether it's a fraction, it doesn't matter. Any quantity minus itself. So if I say something like this, if I say 2,23 minus 2,23, what am I going to get?
0.
0, lovely. Or if I say 100 over 7 minus 100 over 7. What am I going to get as an answer?
0.
0. Okay, so anything minus itself is always going to leave me with 0. So we can take a shortcut with this question, because 3.5 minus 3.5 is going to give us
0.
0. Okay, we didn't even need to do any further work on it than that if we just looked at those numbers really carefully. Well done, Rachel. That was lovely. Good job. Okay, hang on 1 second. Let me just have a look here. This angle, so I need help by 9. How do you get 7 and 3 on top? Okay, so in number 9, how do you get 7? Okay, so this is for, I don't know if I've pronounced your name correctly, but it's Engel, E-N-G-E-L. You asked me a question. You were asking, where does the 7 come in the top? Okay, so to make 3.5 into an improper fraction, you're taking the denominator 2, you're timesing it by the whole number, and then you are adding the numerator. Okay, and then that tells us what to put in the numerator. Okay, so that's where the 7 comes from. Same story with this 3 over here. 2 times 1 is 2 plus 1 is 3. That's where it comes from. Okay.